Thanks, everyone. Nice to be here and back from KubeCon. To be brutally honest, my talk was not at KubeCon. My talk was at the co-located event. So it was next to KubeCon. It was at the AI Day. um, there's a lot of buzz ongoing. Let me quickly introduce myself. Who am I? I'm Mario. I work for a company called Kubernetes. We build a multi-cloud, multi-cluster, multi-environment Kubernetes management platform. All of our tools are at least open core. So if you want, check them out. I'm also working for SIG comms, or SIG contract comms for Kubernetes and SIG K8s infra for Kubernetes. And I'm GTE in Google Cloud and an ARM ambassador. So we heard a lot of all this AI talk and it's the next big thing. And I think that the first day of keynotes was AI only, and a lot of folks just left eventually because they were sick of the AI talks. And my slide is basically disagreeing with the slides of the KubeCon, but good thing is that they were originally presented one day before. So to run AI workload and to have AI workload and to work with AI workload, you do not necessarily need Kubernetes. But Kubernetes itself is a good tool to have all of this AI workload included and managed in there. So basically, it is a pretty well fit to run stuff. We face some issues, not some issues, but some challenges in this field. But let's first start with the benefits. I mean, the benefits are obvious that we can easily scale. So we can utilize the scaling capabilities of Kubernetes. We can utilize the different environments that we have. So we can run on ARM processors. We can utilize GPUs, TPUs of the underlying infrastructure with Kubernetes, and the interface for the consumer stays the same. So that's basically it. But we also face challenges because running Kubernetes is hard. Running Kubernetes in production is even harder. And I think roughly 1 year ago, two people, or I would say two people, started a small project which is called K8s GPT. One of them is in this call. Hi, Thomas. Which is pretty neat. This project, I think, was the fastest project that got into CNCF sandbox status. So the CNCF has different programs for projects where you can basically have projects in, and the status there is sandbox. It is basically a tool to triage and debug your Kubernetes cluster with AI help. The cool thing there is you have 10 interfaces that you can use, and like Gemini, the Amazon AI, you can use OpenAI, and so on and so on. But as we all know, and especially if you come from a Germany, Austria, Switzerland background, you don't trust anyone. And we don't trust any public AI. So basically, we don't trust any vendor that where we would send data to it. K8s GPT also supports an operator, or has an operator for constant monitoring. But to have a look at this is basically when we say we want to utilize AIs, my trust cannot be broken if I trust no one. So we want to basically have our own local AI in place to utilize K8s GPT in our cluster, or to utilize AI in our world. So basically what we need to do is we need to create a magic triangle. The magic triangle is basically your knowledge, because the knowledge that you have about Kubernetes. I mean, on Hugging Face, there are also some data sets that you can utilize, that basically scraps all of the questions in for Kubernetes to fine tune a model. We also need to run our model. To run our model, and this is the or not the limitation, but the requirement that we have from K8s GPT is we want to have it running a local AI. Local AI basically mimics the API of OpenAI, and we need somewhere to train our model. So we need some environment how we can train our model, and for this we basically use Kubeflow. When we have a Kubeflow is basically our all-around toolkit. So it supports like PyTorch. We have a TensorFlow implementation. We can run Jupyter playbooks. We have Hugging Face integration. We can train models there. We can create pipelines for fine tuning. We can also serve a model. Unfortunately, we have no integration yet in K8s GPT for the K-serve part, but maybe we get around to implement this eventually. And it runs everywhere. So you can run Kubeflow. It's an open source project. You can run it everywhere. The problem that we have with Kubeflow is it only supports an out of support Kubernetes version. So if you want to run Kubeflow, you can only use Kubernetes 1.26, and Kubernetes 1.26 went out of support on the 28th of February. And setting up Kubeflow is quite challenging. So for example, if you set up Kubeflow in Google Cloud, you currently can't do it because you can't spawn GKE clusters that run 1.26. So this is something that is still hindering us to have it as a universal platform, and it needs some work, and it's really hard to set up. The other tool that we use is local AI. Local AI is basically a REST API for your AI. It's compatible with the OpenAI specifications. It can run LLMs. There also for generating images, audio, and you don't need a GPU. So you can basically run, if you have the fine-tuned model, you can basically run it purely on CPUs. And it also supports most of the public model or the open models that are currently available. I think when Gemma was released, it took like 1 month for them to implement Gemma as a valid LLM background. So how does the architecture now look like? And it's not easy. So to clarify this is some work that you need to put into this, especially when it comes to dataset preparation, because you need to first create a data set, find the valid information of the data set. So for example, I am currently working with some folks that we take the Kubernetes documentation and create a data set out of the Kubernetes documentation, that you can basically have a model that gives you more educated answers for the Kubernetes space itself. And then you need a fine-tuning script. So if in my case I use PyTorch to create it because I'm not that good in Python, and PyTorch was pretty easy to implement. And then you pack basically everything into a Docker container, use Kubeflow pipelines to run the training job in Kubeflow. And there's the good thing that you can basically spawn multiple workers everywhere. And then you need to export the model. So then you need to export the fine-tuned model. And the important thing is that you save it as a GGUF file. The GGUF file is basically a specific requirement from local AI, how a model should look like. And then what you then consume is then your K8s GPT, either your CLI or your operator is then consuming local AI as the endpoint with your fine-tuned model.
A quick question, Mario. Yes. We have a question from the audience, and that is if local AI is similar to Ollama.
I think yes. It is basically, Ollama does not support all of the models as far as I know yet, but it is pretty similar. The thing with local AI was it was just the tool that I choose because we have the integration in K8s GPT for it. So if we have to integrate, it's just you need somewhere to run it. So I haven't had a deeper look in Olama, but it's as far as I know, Olama can run models, so that's basically then yeah, it's the same thing in the end. Yeah, jumping back to where we are. I mean, we are currently at the very beginning, and this whole thing is getting bigger and bigger. And I mean, when you look at PyTorch scripts that you can find on the internet, you also clearly see that they are written by data scientists. So they are not following software engineering principles. They are hard to maintain at some point, and they are not optimized. And I think that this will change in the coming months. I mean, when we saw the pace, how everything took up, basically everything that I tell you now is obsolete in half a year probably, because we have a fully fledged integration into Kubeflow. There are other projects that will come up. I mean, the CNCF pushed really hard for Olama at the keynotes, and it's really moving fast. And I encourage everyone to at least dip their toe into the cold water, because just experimenting helps you to understand this whole field and demystifies a lot of stuff, and you can see basically the limitations that you're running into. And the main problem that most of the companies have currently is find a use case. And to be honest, having a debugger that helps you, like, what is going on in my cluster and gives you an easy solution is, in my opinion, one of the most valid use cases that we currently have for AI workload, because a lot of companies are just playing around and searching for a problem for a solution, and that's the wrong way, right? Because you should have a problem and then search for the solution, and not the other way around. And that's basically for me, with only 2 minutes being over. Thanks everyone. I hope it gave some insights, and let's see in half a year where we are. Let's put it this way. Maybe I have a fine-tuned model for you that everyone can use with all of the documentation of the CNCF projects.